This video is the companion video to the variables lecture. This time, instead of just talking about variables, we're going to practice using them. In your Blackboard shell, if you navigate to the course, and this week, you should have a C# file that you should be able to download. And this has the problems that we're going to work through inside of it already. So what I would suggest is create a new Unity project, and once that's up, we can import in that C# file. All we need to do to import that in is once we have it downloaded is we can just drag and drop it into our assets folder and it will import it in for us. The last thing we need to do is we do need to put this onto an object in our scene so that we can run it and see stuff occur in our console. To do this, we can just place it on any object in our scene. We don't have to be picky. I created a new empty game object and renamed it, and you can just do that if you want to by right-clicking in the hierarchy and choosing Create Empty. We can then give this a name. I usually like to name it the same name as the script I'm about to put on it, so it's easy to find. Then we can just drag and drop that on that game object in the inspector. So now we can see that we have that there. Next, we just double click on that script to open it up and we can start working with it. Once you open your script in Visual Studio, the one thing you should check on to make sure that Visual Studio is talking to Unity correctly is up here in the upper left, it should say Assembly C#. If it says miscellaneous, we have to kind of fix something back in Unity. And I'm going to show you how to do that now, just in case you are experiencing this. So if it says Assembly C#, this is fine. If you open up a script and it says miscellaneous, we do need to go back and fix something. So you know it's correct. I'm going to show you how to fix this if it does occur to you. So I'm going to close this. And then in Unity, I'm going to go to Edit, Preferences, and I'm going to find the external tools right here. This external tools right here. What we want to make sure we see is Visual Studio, whichever version you're using, should be underneath this external script editor right here. So if it's not there, make sure that you select it and then click Regenerate Project Files. And that should fix that problem. One thing I do want to change while we're here is I do like to change our runtime colors. And since we have the preferences open, we might as well do that. You'll see how this works a little bit later when we actually run it, but it's going to be helpful to tell when we're running our project. So I'm going to go to Colors, and underneath Play Mode Tint, I'm going to change this to something very obvious. I like to put it on a really bright pink fuchsia myself. And what this does is when we hit play, it's going to tint our screen that color. The way that Unity works is when we're in play, we can still make alterations to our scene. We can add things to it, and we can, do different things. But when we hit stop, when we're stopped playing, any alteration we made during runtime disappears. So sometimes it's hard to remember that you are actually in play unless we tint it. And you could be making changes to your Unity scene that are going to disappear when you turn it off and you didn't realize it. So making that play mode tint something obvious can be really helpful. So with that, let's jump into working with variables. And the way that these demos work is that you have some problems listed up here in the comments for you to work through. So we're just going to kind of go through all of them. The first one is to declare and define examples of the 5 variable types discussed in lecture and print them to the console. So let's tackle this with the first part of just declaring and defining the 5 variable types talked about during the lecture. And we're just going to do this in the start so that when we run our code, it automatically will run any lines of code that are in the start method. So it'll be easy to see what we're doing. So first, let's declare and define our 5 variables. So the 5 main ones are ints, floats, chars, strings, and bools. So let's start with int. So we're going to type int, and if it's set correctly, it should kind of start to autocomplete. You should see this pop up here, and it should turn blue. This means that Visual Studio knows that you're working in C# and understands what you're about to type. We then want to give it a name. We're going to call it my int, and we are going to do this in camel case, which means that the first letter is lowercase, and the second word, there's no space, the second word is uppercase, so it's very easy to read. We're then going to set that equal to 5. And since this is C#, we don't end things in periods at the end of our statements, we end things in semicolons. Notice that Visual Studio is very good at showing when there are issues. So for instance, we see the little red squiggle. If we hover over that, it tells us what the problem is. It says semicolon expected. So if you see that, it just means that you forgot to put your semicolon in. Let's do floats next. So we're going to do float. Notice it is turning blue. That means we are typing it incorrectly. My float. We'll set that equal to 6.5f, semicolon. This f is important. It means that we are working with a float. In fact, if we forget it, it's going to yell at us saying you forgot something. If we hover over it, it just says literal or type double cannot implicitly be converted to type float. Use an f suffix to create a literal of this type. Long story short, it just means that whenever you put in a value inside of a float, 6.5, 3.2, 2.0, you just need to put an F at the end of it so that it knows that you are trying to work with a float number. So if you ever see that error, that's what it means. Let's do a character next. We don't write out character, we just write char. So I usually just refer to this type of variable as a char variable. We're going to call it my char, and we're going to set that equal to a. And the way that we need to do this is whatever character that we want to give it, we can't just say a. Oops, see, it auto-completes to weird things. We have to use the single quote. And notice when I've just typed one, it put the second one down for me. And whatever character we want inside of that quote. You need to do this for any character when you're defining a character. And then obviously the semicolon at the end. Strings are similar to setting up a char. What we do to define a string is we write the full word string, we give it a name, my string, and set that equal to, but instead of using the single quotes, we use the double quote. And if I type my first double quote, notice it does complete it by giving me a second double quote so that I can then put whatever string I want in there. So I'm going to just say hello world and end that with a semicolon. Last, we are going to define a Boolean. We don't write out Boolean though, we just write bool. Remember, this means true or false. So we can either set this to true or false. That's it. I'm going to give it a name, my bool, and set that equal to true. And we do write out the word true. Notice it does turn blue, so it does understand what we're doing. It's either going to be true or false. And notice that this also does turn blue, but I want to make it true. So let's do true. So this is a great example of how to declare and define the 5 main variables. Next, we want to print this information to the console. And since we are using Unity to kind of run our programs, we're going to use a Unity specific thing to print stuff to the console. In Unity, if you want information printed to the console, what we can type out is debug.log. We then have a set of parentheses and a semicolon. What gets printed out is whatever is inside of here. So we can just say inside between those parentheses, my int, and it will print out whatever is being stored inside of my int. So in fact, let's do that real quick. I'm going to make sure I save. I'm going to hit Control S to save. The little asterisk disappears next to the file name, so we know that we did save correctly. And I'm going to go back to Unity. I'm going to go to my console, and this is fine. It's just a couple of warnings. The yellow isn't important. It would be important if we got errors. It's just telling me I haven't done anything with those variables yet, which is fine. I don't care. We're going to do stuff with that in a second. I'm then going to hit play. And we can see that it printed out 5, which is true. That's what was being stored in that variable. So let's go ahead and let's print out the rest of those variables. And it's very simple. It's just debug.log my float, debug.log my char, and I am remembering those semicolons at the end, debug.log my string, debug.log my bool. So let's finish that and let's run it and see the results that we get. So now we see 5, 6.5, A, hello world, and true. So that's it for the first question. Let's look at number 2. Practice converting one variable type to another. So if you remember, I'm gonna label this just so if we do need to come back and look at our notes, we can. Declaring variables. Then down here, I'm going to put converting variables. If you remember from the lecture, it was talked about that in C#, variables are strongly typed, which means that if you say a variable is an int, it can only hold an int. If a variable is a string, it can only hold a string. But there are instances where you are going to want to take what is being stored in one type of variable and throw it in another. And this is where the converting comes in. And each one has kind of its own little twist on it. So we're going to kind of practice going through some of the major ones. So the first one we're going to do is putting a float into an integer. And we're just going to make a new variable called float to int. And we're going to put my float, we're going to store 6.5 into there. And the way that we do that is we say, we're going to set this equal to, we then put in parentheses int, and then we put our float. So that's just my float. And that's it. We should probably print this out just to make sure it is working. So debug.log, we're going to say print out float to int. And let's see what we get real quick with this one. So the float is 6.5. So let's see what happens when we run it. We now get 6. The way that this conversion works, if you remember, 6.5, if you're in a math class, you would normally round that up to 7. That's not how this works when you convert floats to integers, is it just cuts the decimal off. There are other ways to do that if you do need to round it up, but this method just takes that decimal away. It doesn't do any kind of rounding. Let's do int to float, where we want to put an integer into a float. This one's really easy. So we're going to define float into int to float, and we're going to store the integer in there. This one, all we have to do is put my int into it. That's it. We don't have to do anything special for it. We can just store integers into floats. So we don't have to add anything to this. We could print this out. I'm not going to go back to the console until I go through all of these so we can see them all at once. Let's next do int to string. What if you needed to store this integer in a string variable? So we'll do a new string variable. We're going to name this one int to string. And the way that you do this is you do your integer, so my int, and then you add on the end dot to string, parentheses, and then your semicolon. So anytime you need to turn an integer to a string, you just add that on to the end of it, and it should be good to go. What about doing a string to an int? So what if whatever is being stored in here, you need to put into an integer? That one's a little bit different. And we do need to be kind of careful with this one, because if we try to put in a string that doesn't actually have an integer being stored in it, like just not numbers, you're going to get an error with that. So you need to make sure you're working with strings that do just hold numbers. So I'm not going to try to put hello world in there because it's going to error, and you can try that out to see what the error looks like. Instead, I'm just going to make a new string to throw in there. So int string to int is equal to, and what we need to do is we need to do int dot parse with parentheses. Inside of here is where we put our string. So we don't want to do this because we're going to get an error because it's holding hello world, not a number. We're just going to make a new string in here, and we can just do this straight up. We don't need to make a new variable. We can just put the double quotes and say something like 90, and that is a string that's going to get turned into an integer and stored into here. So we can print that out. String debug.log, string to int, and we'll be able to see those results. The last one I want to go over is turning a string into a float. This one is similar to turning a string into an int, where that float does need to be a number. If it's not a number, you're going to get an error. But just so that we can have some practice, make a new float variable called string to float. And we do this, it's very similar to integers, but rather than int.parse, we just do float.parse. Then inside of our parentheses, we have to give it a string that is a number. And again, we can't use hello world, it's going to error because it's not a number. So we're just going to do 22.875. And we finish that off with our semicolon. And let's print this out too. Debug.log, string to float. So let's see what we get. Let's run this all. So we got our hello world true. So down here is all our conversions. So we got our 6, we got our 5, we got our 90, we got our 22.875. So we are getting the correct results in those conversions. So let's keep moving on. Create 3 class level scoped integer variables named first number, second number, and results. So if you remember, we talked about scope, and right now we have these variables here, and these are scoped to just this start method. If we had other methods down here, and we're going to go into methods in the next section, we wouldn't be able to access these in our other methods. We also have the issue of once this start method is done running, these variables disappear. So what if we had information we needed stored in variables that we needed outside, not only outside accessed by another method, but we needed to hold that information outside of when this method is done running. That's where the class scoped variables come in. and we put those up here, inside of this class here, the first curly brace, but outside of any of the methods. And the top is usually a good place to do that. So I'm going to set this, I'm going to make a little note saying these are class scoped variables. And I'm going to come down here and leave myself a little note that these are local scoped variables, just so I remember. So let's see, I need to do 3 of them: first number, second number, and results. And I'm just going to give them some values as well, even though it doesn't quite say that, but we're going to practice that. So these are going to be ints. First number is equal to 20. Int second number is equal to 10. And I'm not going to set the results yet. We can just do that too. We can just say int results, and we can set that later. One thing I would like to note, since these are class scoped variables, we do have to think about their security level. I didn't define their security level here, which means that these are by default private variables, which means if we save this and we go back over to Unity and we take a look, we don't see those variables on here. If I were to come back here and make these public, I'll make all 3 of them public, save them, hop back over, we now see those variables in the Unity editor. So now these are public. I probably don't want them all public. I'm going to change the first 2 to private so that we don't see them. We're just going to see the results. There we go. Okay, so our class scope variables, we did also set the security level, even though it didn't tell us to do that, but it's always a good practice to do that. Next, practice using the arithmetic operators using the 3 class level scope variables created in the previous step. So that's those up here. And I'm going to do that down here underneath all this. So let me write a little note. And we're going to do this by storing the results in results. That makes the most sense, doesn't it? That's why we have this up here. So let's first add the first number and second number together. So since we defined this variable already up here, we don't write int again. In fact, if we start with writing this, we're technically making a new variable, a local scoped variable called results in here. We're not accessing that class one, so that's not correct. We just want to write results. And we're going to set that equal to first number plus second number. We can then print that result to the console using debug.log, and we can just put results in here. Let's do subtraction next. Results is equal to first number minus second number. We'll print that out. Let's do multiplication. Results is equal to first number times second number. And I don't really want to type this line of code out multiple times, so what I'm actually going to do is I'm going to highlight this. I'm going to hit Control-C to copy, and then I'm just going to paste it in down here. There's no reason to type that all out multiple times, so I'm going to kind of shortcut that so I don't need to do that. Let's do division. Results is equal to first number divided by second number. Then I'm going to paste in us to print that out. Let's do our modulus, or modulo, I think that's how it's pronounced. Results equals first number We usually just say mod second number. So it's first number mod second number is usually how you would say that. And let's print out the results. Is that all we need to do for this? Let's do the rest of them. Let's do some of the shortcut ones that are super handy, just for practice. We're going to do first number plus plus. Remember that adds 1 to the current value of first number. And we'll print that out. Debug.log first number. We'll do second number minus minus, and then print that out. And let's do just practicing some shorthand with the adding something to the name of the the current variable, like the current value being stored in there. So rather than first number is equal to first number plus 5, we can rewrite this instead as first number plus equals 5. This is the same as this. It's just a little bit quicker to type. So I'm going to comment this out, but I'm going to leave that in there in case you want to refer, maybe make a note to yourself that this is the same as this. And let's print that out. And this, remember, works on addition. You can do subtraction, you can do multiplication, and you can do division that way. All right, let's go and see the results of all this. So let's hit run. And let's see, so 30, which is 20 plus 10, 20 minus 10 is 10, 20 times 10 is 200, 20 divided by 10 is 2, 20 mod 10 is 0, and then we just added 1 to 10, added 1 to 20, minus 1 from 10, and then added 5 to that 21, so we are getting the results that we need. Okay, I think next is we're going to work with some strings, practice a little bit of string manipulation. So let's see. Create a class level string variable named toPrint. So remember those class ones are up here. So we're just going to say string toPrint. And we're not going to set it equal to anything. And by default it's private, so we're just going to leave this as is. Next, create 2 local string variables in start named first and last and set them equal to your first and last names. All right, so down here, we are going to make a note saying we're doing strings down here. So first, let's define those local string variables. So string first, I'm going to set this equal to my first name. Remember, we do use the double quotes. Amber. And then string last is equal to Johnson. And we are going to add this to toPrint. We're going to concatenate these. Right now toPrint is empty. So let's concatenate our first and last name into toPrint. So we can just say toPrint is equal to first plus last. So it's just going to stick this one and then this one on the end of it. And let's print it out and see what we get. Just print out toPrint. And let's run those results. And we see that I get my name printed, but that's not really formatted super well, is it? It's my name but it's kind of mashed together, and that's not really how we would normally print out somebody's name. So let's take a few moments, and let's make this look a little bit more elegant than this. It's not too hard, and it's good string practice. So the first thing we want to do is, this was good practice. I don't want to clear that out. But what if we do have an instance where we need to clear out our string? Like we want to get rid of my first and last name being stored in toPrint. We just want toPrint to be blank. All you need to do if you ever need to clear out a string so that there's nothing currently being stored in it is we can set toPrint equal to, and we do the double quotes, but we don't have anything between them. This clears out any string being stored in there, and we just have an empty, like it's just, there's nothing, so that we can kind of concatenate stuff back onto it. So let's kind of practice this a little bit. We could, in theory, just set toPrint equal to first, and that would put my name on there. But let's try another way to show another way that we can put stuff onto strings. We can say toPrint plus equals name, and I'm going to put a colon and a space. And for now, I'm just going to put at the end another debug.log for toPrint, just so we can see what this is looking like as we're kind of adding things on. So we cleared it out, and then we added this string here that says name. Let's see what happened. Oops, I was accidentally running it. Bad on me. Hold on. Let's try that again. So we printed it out. It was ugly. We cleared out the string. We added name to that empty string. I can then add my first name onto it. And I'm just going to be doing this one line at a time, so you can kind of see how you can do this with strings, but you, in theory, could do this with one long line of code. And if you're comfortable doing that, go for it. You could try it out. But if you need to break stuff like this up because you're new to coding, that's fine too. So let's add my first name to that, and I can do it the same way as up here. This is, again, just shorthand for toPrint is equal to whatever is currently being stored in there plus first for my first name. And we can leave this one this way, but just know this is just shorthand for this. So it's a lot easier just to type that. So we have name with a space. We're then going to add my first name to it. toPrint, I'm going to add a space, and then toPrint, I'm going to add my last name. And let's print this out. Let's print this out and see what it looks like. So we got name is equal to my name, and it's nice and spaced, and it looks a lot better than this. We can practice kind of putting this all into one line of code. So, we started with this, we cleared it, we added this, we added this, we added this, we added this. What if we just wanted to make this a little bit cleaner? We don't necessarily need to clear it out to do this, but again, that's good practice to know that you know how to do that. Instead, we could just set the whole variable equal to something new. And we're going to do that right now. So we're going to say toPrint is equal to, I'm going to give myself the title of the concatenator. I'm going to do my little colon and a space plus first for my first name, plus I'm going to do the double quotes, but I'm going to put a little space in there so that it'll put my name, it'll put a space next on that string plus last, and then end in a semicolon. Then we'll do debug.log to print this to the console. So let's hit save and let's go to Unity and see what our final result is. We get the concatenator, my name, and the spaces are nice. So 2 different ways we can do this. Whichever way is the most comfortable for you right now, especially if you're starting to learn code. If this is better, that's fine. If you're a little bit more advanced, this is moving in the direction of where you eventually want to be with working with strings. And that's it for this demo. We were able to go through all of our questions up here. Hopefully this was helpful kind of to work a little bit with the code, and you should be ready to move on to the next lesson about methods.